In our previous class, we had been through how to download and install Cedar Logic Simulator. And in this lab session, let's see some basics of IC numbering. So here IC means integrated circuit, or in other words, the logic gates that which we'll use in our lab session. So all these logic gates will be installed in these ICs, and each of these ICs will have their own name, and as a part of name they will be assigned some number series. And with these number series, we can identify what kind of IC is that, whether it's NOT gate, AND gate, or OR gate. So in this lab session, we'll be going through basics of ICs and how they are actually named, wherein we'll also go through its packaging, the kind of package used for the IC. I'm your Benak Patel, and let's get started. I hope this IC is visible to each and every one of you. So let me rotate it. So this is how our IC actually looks like. So this IC is 7408, and here 7408 is used to represent AND gate. Now how exactly am I able to tell that this is 7408 IC? Here if you clearly observe, they have quoted 74, then followed by some alphabets HCT, then followed by 08. Let me have one more pick of it. Okay. Here you can clearly see that here we are having 74, then followed by 08. This refers to AND gate. So this AND gate over here on a whole is a 14 pin IC. So this 14 pins is equally divided into two equal halves. So 14 by 2 is 7. So we'll have 7 pins on each side. 7 on to the left of IC and 7 more on to the right. So here if I start to count from here, so this is my pin number 1, this is pin number 2, this is pin number 3, this is pin number 4, this is pin number 5, this is pin number 6, and finally this is pin number 7. So there are 7 pins on each side. So I can think of this as left side of my IC, and in a similar way I'll also have 7 more on to the right side of my IC. Now you might ask me a question that why should I start to count from here? I could have started counting from the bottom, like this is my pin number 1, 2, 3 and so on. So why did I start to count my pin numbering actually from here? So there is a reason for that. The question is how to identify top of an IC. So in order to identify top of an IC, so if you clearly observe here, so there is a notch like kind of structure. So notch is given over here in order to represent top. So notch over here actually represents top of an IC. So by now we got to know that this is the top of an IC, and whereas at the bottom it's clearly evident that there is no notch. So this is how we can make out top of an IC. But why should I start to count right from the left side of the IC? I could have started my pin count from the right side of the IC. In order to avoid such kind of numbering confusion, what I have given is, here if you clearly observe, there is a circle. There is a circle given very next to this notch. So this circle over here actually signifies pin number 1, and it is actually trying to tell us that we got to start our pin count from this end. So this is my pin number 1, 2, 3, 4, 5, 6, 7. On the other hand, I will be having right exactly opposite to this pin number 7, I'll be having pin number 8, followed by exactly opposite to pin number 6, I'll be having 9. Likewise, pin number 10 exactly opposite to pin number 5, pin number 11 exactly opposite to pin number 4, pin number 12 exactly opposite to pin number 3, pin number 13 exactly opposite to pin number 2, and pin number 14 exactly opposite to pin number 1. So this is how we can identify top of an IC. After identifying the top, so the next question is how to identify starting pin, or in other words, how to identify pin number 1 so that we can start to count. In order to do so, most of the ICs are associated with notch. By looking at the notch, I can make out the top of an IC. By looking at the circle very close to this pin, I can make out that is pin number 1, and that's where my pin count starts. So by now we did got to know that each of these logic gates are associated with their own number series, and in our lab what we'll do is we'll not call it with AND gate name, but instead of that we'll make use of this numbers that which are used to actually identify the kind of gate that which is being used. Now we do also have few more alphabets on this IC like MM, followed by HCT. We are having one more alphabet over here like N. So let's go through all of this in detail. So first of all, let's take up the starting two alphabets. So right now here, the starting two alphabets are MM. So this MM over here actually denotes IC manufacturing company name, where MM is used to denote a company by name Fairchild Semiconductor. So Fairchild Semiconductor is a leading IC manufacturer that which has manufactured this IC, and in order to denote this company as Fairchild, MM is used. There are also other competitors for this Fairchild Semiconductor company like Texas Instruments, and this company is denoted with initials SN. So I don't know why they have actually kept specifically SN in order to denote Texas Instruments, but this is how it works. Then we have HCT. HCT is used to denote to what particular logic family chip belongs to. HCT over here actually stands for, or it's used to denote, high speed CMOS with TTL logic levels. CMOS is an acronym for complementary metal oxide semiconductor. TTL logic. TTL is transistor to transistor logic. So this is the actual meaning of the other three alphabets that which are usually displayed. And finally, so what do we have here? Finally, we are having N. And let's see what is this N used to denote. So the last alphabet in the nomenclature, we are having N, where N is used to denote the kind of packaging. So N over here actually denotes that it's a dip package. It's called as dip package, or it's also called as P-dip package, where P-dip is an acronym for plastic dual inline package. And over here we do also have the other kind of packages, SOIC, that which are usually smaller in size. So SOIC over here is an acronym for small outline integrated circuit. So it all depends upon the kind of application in which you are trying to make use of. So we usually go with dip kind of packages back in our labs in order to do experiments. So these dip kind of packages are quite handy to handle, but whereas SOIC is very smaller in size, so it's quite difficult to handle it. So thereby we usually try to avoid small outline integrated circuit kind of packages back in our labs. So we'll not make use of these packages in our labs, whereas these are largely used in applications. You might ask the question why SOICs are greatly used in applications, and the answer for that is smaller in size, because digital electronics is all about minimization. And if you ask any customer about what kind of form factor does he likes in his product, and his answer would be to have a smaller form size. So thereby usually industry people usually prefer SOICs kind of packages rather than dip kind of packages. But whereas back in our labs, we usually go with dip kind of packages. So this is about some of the basics of IC nomenclature.